Welcome to a fascinating adventure, a journey that will take us to the heart of mathematics. Prepare to explore a universe where numbers come to life and letters reveal secrets. Today, we will unravel the mysteries of algebra. Algebra is much more than a school subject. It's the secret language of mathematics. It allows us to describe patterns, solve puzzles, and understand the world in a completely new way. It's a powerful tool that unlocks the potential for logic and critical thinking. Our first stop on this exciting journey is the foundations of algebra. Here we'll build the solid foundation that will allow us to understand more complex concepts in the future. Think of it like learning the alphabet before writing a novel. Our goal is clear: to unravel the mysteries hidden behind numbers and expressions. We want you to understand not only how things work, but why they work. Get ready for an educational, intriguing, and above all, fun experience. Let's start at the beginning. Real numbers. Imagine an infinite universe of numbers, each with its own place and purpose. Real numbers are the foundation of everything we do in mathematics, the canvas on which we paint our equations. This vast set includes the numbers we use for counting, such as 1, 2, and 3. They are the first numbers we learn, essential for quantifying anything in our daily lives. From counting sheep to counting stars, they are our oldest companions. It also includes the numbers we use to measure distances, whether large or small. Think of the length of a table or the distance between planets. Real numbers allow us to express these magnitudes precisely. We cannot forget negative numbers, which help us represent concepts like debt or sub-zero temperatures. They are just as important as positive numbers, adding an extra dimension to our numerical understanding. They allow us to move in both directions along a line. Decimal numbers are also part of this family, perfect for expressing parts of a whole with great accuracy. They are fundamental in science, engineering, and everyday life, from prices to precise measurements. They allow us to go beyond whole numbers. And of course, fractions, which represent divisions of a whole. They are crucial for understanding proportions and fair sharing. Fractions teach us that numbers can be parts, not just whole units. Think of real numbers as a complete map of the numerical world. Every point on this map has meaning and a relationship to the others. It is an indispensable tool for navigating the vast ocean of mathematics. The history of numbers is as old as humanity itself. Numbers have existed since humans first needed to count, trade, and organize their lives. They are a fundamental invention that propelled the progress of civilization. Thousands of years ago, the Babylonians used complex number systems for their astronomical and commercial calculations. Their ingenuity laid the foundation for many of the mathematical ideas we use today. They demonstrated an advanced understanding of positional notation. The Egyptians also developed their own numerical systems millennia ago, which they used to build pyramids and administer their vast empires. Their numerical legacy is proof of the universal need to count and measure. Mathematics is a global heritage. A simple example of a real number is today's temperature. If we say the temperature is 25 degrees Celsius, we are using a real number. It is a concrete value that we can place on our infinite number line. Now that we know about numbers, let's talk about the tools we use to manipulate them. The basic operations. These are addition, subtraction, multiplication, and division. They are the foundation upon which all arithmetic, and therefore algebra, is built. These operations are like the essential ingredients in a recipe. Without them, we couldn't cook anything in the world of mathematics. Each one has a unique and fundamental purpose for solving problems. Addition allows us to combine quantities. Subtraction helps us find differences. Multiplication is an efficient way to add repeatedly, and division allows us to share or group. Mastering these operations is the first step toward mathematical mastery. It's interesting to think that multiplication, for example, was initially based on repeated addition. Multiplying 3 by 4 is the same as adding 3 4 times. This connection reveals the underlying simplicity of mathematics. Mathematics is, in essence, a process of simplification and efficiency. It seeks to find the most direct and elegant ways to solve complex problems. Basic operations are the perfect example of this pursuit of efficiency. Let's imagine a very simple example. If we have 3 apples and we are given 2 more apples, how many do we have in total? The answer is 5 apples, which is expressed as 3 plus 2 = 5. This is the power of addition in action. This is where algebra truly begins to shine and reveal its true power. Manipulating algebraic expressions is the art of working with numbers and letters to solve problems. It's where logic and creativity meet. Algebraic expressions are like puzzles waiting to be solved. They contain variables, which are letters representing unknown quantities, and numbers, which are fixed values. Our job is to unravel what those letters mean. The key to these expressions is the use of letters or variables, along with numbers. These letters allow us to generalize problems and solutions, applying them to countless situations. They are the heart of algebraic thinking. It is a fascinating historical fact that algebra, as we know it today, was developed by Arab mathematicians. Their work during the Middle Ages was revolutionary and laid the foundations for much of modern mathematics. Their legacy is immense. Figures like Al-Khwarizmi, whose name gave rise to the word algorithm, were pioneers in this field. His treatises not only introduced the concept of algebra, but also systematized methods for solving equations. It was a golden age for knowledge. This development represents a legacy of wisdom that has transcended cultures and centuries. Algebra is a testament to how knowledge is built and shared throughout human history. It is a truly universal discipline. Let's consider an example. If X represents the number of candies you have, the expression X plus 5 means that you got 5 more candies. The X is an unknown that we can discover, and the expression helps us describe a situation. If we know that X is 10, then X plus 5 would be 15. But if X is 20, then X plus 5 would be 25. The variable X allows us to talk about any quantity of candies without having to specify it immediately. This allows us to create mathematical models for real-life situations. We can describe relationships between quantities without knowing their exact values. It's a way of thinking in terms of patterns and relationships. Algebra empowers us to solve problems that would be impossible to address using only numbers. It allows us to move beyond the concrete and enter the realm of the abstract. It is a tool for higher-level thinking. When we manipulate expressions, we are applying logical rules to simplify or transform them. It's like a game of chess where each move has a purpose and brings us closer to the solution. Practice is key to mastering this art. Understanding how to combine terms, how to distribute numbers, and how to factor expressions are fundamental skills. These techniques allow us to simplify complex problems and make them manageable. They are the essence of algebraic problem solving. Algebra is the bridge between arithmetic and higher mathematics. It is the language that allows us to talk about functions, equations, and graphs. Without it, many branches of science and engineering would not exist. Think about how engineers design bridges or scientists model the weather. They all use algebra to describe and predict phenomena. It's an indispensable tool in almost every scientific and technological discipline. The beauty of algebra lies in its ability to generalize. Once we solve one algebraic problem, we have found a solution to an infinite number of similar problems. It is an astonishing intellectual efficiency. It teaches us to think abstractly and see the underlying relationships in problems. This skill is valuable not only in mathematics, but in any field that requires logical thinking and problem solving. It's a life skill. So when you see an algebraic expression, don't see it as a meaningless jumble of letters and numbers. See it as a coded message, a puzzle waiting to be solved. Every expression has a story to tell. Simplifying an expression is like untying a knot. Step by step, we apply the rules until the expression becomes clear and concise. It's an exercise in patience and precision. Remember that each variable represents something. Each number has a value, and each operation has a meaning. Together, they form a powerful language that allows us to describe and understand the world. Algebra is a constant adventure. We've covered a lot of ground in this first episode of our algebra journey. We've explored the vast universe of real numbers, from counting numbers to fractions and negatives. We understand that they are the foundation of everything. We've also reviewed the basic operations: addition, subtraction, multiplication, and division. These are our essential tools, the fundamental ingredients for any mathematical calculation. They are the foundation of our toolbox. And most excitingly, we've introduced the manipulation of algebraic expressions. We've seen how letters and numbers combine to form puzzles that we can solve. This is where the true magic of algebra begins to unfold. Think of what we've done today as laying the foundation for a great building. Real numbers are the ground, basic operations are the tools, and algebraic expressions are the first bricks. We are building something solid. To all of you curious young people and algebra students, remember this: mathematics is a game of discovery. Every problem is an opportunity to learn something new, to expand your mind. There are no limits to what you can achieve. It's an exciting challenge, an intellectual adventure that will reward you with a deeper understanding of the world. It's not just about getting the right answer, but about enjoying the process of getting there. The journey is as important as the destination. Don't be afraid to make mistakes. In fact, every mistake is an invaluable learning opportunity. Mistakes show us where we need to improve, where we need to adjust our understanding. They are stepping stones to success. So take a deep breath, trust your curiosity, and keep exploring. The world of algebra is vast and full of wonders waiting to be discovered. Every step you take brings you closer to mastering this universal language. Get ready for the next episode, where we'll delve even deeper into algebra. We'll explore equations, functions, and much more. The adventure is just beginning, and we're excited to have you on board. See you next time.